Hi everyone, Quiveen here from the comfort of my kitchen. In today's video, we are going to take a look at something that we thought was an exoplanet. We're going to take a look at a former candidate exoplanet, which has now been discovered, well, not to be. We're going to be looking at this particular star, which was believed to have a planet going around it, but we have now learned that it was actually a mistake. Mistakes happen. Even in astronomy, even when the brightest minds are working on discovering or ensuring that certain things are or aren't, mistakes can still happen, and they do. We're going to be looking for a particular constellation here, the constellation of Eridanus. It is not very visible from Ireland at this time of the year, and to be honest, it's not very visible from Ireland at any time of the year. All of it certainly isn't visible. Even here, where we're seeing the sun at its highest, pretty much, where we're very much coming close to the summer solstice. So because this is our view in the summer, looking at the sun, we can see the ecliptic up at pretty much its highest. If we were to look in this direction in winter time, when we were close to the winter solstice in the middle of the night, we'd see the constellations in pretty similar positions. If there was a full moon, the moon would be there instead of the sun. So, of course, planets like Mercury certainly wouldn't be visible. Planets like Jupiter, Uranus, the moon, Mars could be, depending on the year. But looking in this direction, we can see some famous constellations. Orion, of course, Canis Major, one of the most famous, Gemini, all very famous constellations. Taurus is in there, pretty obscured by the sun, but we can see the Pleiades next to Jupiter and Mercury. The constellation we're looking for is this long line down here. In previous videos, we've looked at how the constellations can often be deceiving. For example, this slightly wonky line is supposed to be a ram, Aries the ram. It can be hard to imagine what this long squiggly line is meant to be, but it's meant to be a river. And that, I think, makes a little bit of sense. So here we go. Here's the images of the constellations. And there is the river of Eridanus. I'll bring up the names. Yep, Eridanus. There we go. So that is the constellation of the river. We can't see its brightest star from here in Ireland. If I get rid of the ground and we follow this river down, as you can see, it's a pretty big constellation. It's the sixth largest constellation out of the modern 88. Down there is Achernar Alpha Eridanus. So that is the brightest star in the constellation. If we move back along this line, you'll see that a lot of the stars, there's Phi Eridanus, some of them, there's Iota, I believe, Eridanus. A lot of them have these Greek names. Bmeme, U3 or Upsilon 3 Eridanus, or 43 Eridanus. There's lots of different names for some of these stars. Even if we hop back here, that's Skeptrum, maybe it's this one, Cursa, yeah, Beta Eridanus. So Beta Eridanus is supposed to be the second brightest star in the constellation after Alpha Eridanus. But this doesn't always work. People made mistakes when these stars were being assigned designations, particularly the Bayer designations, the ones with Greek letters mostly. A lot of the comparisons were being done by eye. There wasn't very precise optical measurements of the brightness, and moving across the sky from left to right, from top to bottom, also was a factor to the naming. So we've got up here Betelgeuse Alpha Orionid and Rigel there, Beta Orionid, simply because Bayer, the astronomer who made these definitions, he started from the top. The first brightest one was Alpha, and then the bottom brightest one was Beta, even though its magnitude 0.15, and if we click on Betelgeuse there, it's magnitude 0.45. They're very close, but Rigel is actually brighter than Betelgeuse, despite the fact that their names seem to be the wrong way around. If we take a closer look in at Eridanus, here I believe, yep, O2 or Omicron 2 Eridanus or 40 Eridanus. The numbers here are the Flamsteed designation. It's just another way, really, of naming the stars and breaking them up, making sure that they can all be referred to individually and specifically without getting mixed up. There is other Omicron Eridanus. The fact that this is Omicron 2 Eridanus, that implies that there's an Omicron 1 Eridanus, and there could be an Omicron 3 as well. That can get confusing. So the Flamsteed designation is sometimes used instead of the Bayer designation in situations like this. These catalog numbers, like the Hipparcos catalog, they're very hard to remember, these strings of digits for specific stars, so they're more useful in digital stuff like cataloging. If I assume, maybe it has been updated, I would assume that the stellarium hasn't quite updated to realize that the star I am looking for is now believed not to have an exoplanet, although maybe it did already figure that out. It should, I believe, be 40, because I am not a Trekkie, so I am not as intimately familiar with the solar system that the Vulcans come from. The planet Vulcan is supposed to orbit a star in the constellation of Eridanus. I believe it was 40 Eridanus. The fact that this says double star makes me think that this is the correct one, because the Eridanus system that I'm looking for is a multiple star system. And Cade, the name, pretty sure this is the right one. No matter how close we look, the stars don't seem to split out into their separate components, being a double star system, and it's no longer labeled as having an exoplanet. There is the possibility that my version of Stellarium never got to the point of labeling it with an exoplanet. I may not have done that update, but there was believed to be a planet going around 40 Eridanus, and according to Star Trek, that is where the planet Vulcan orbited, around 40 Eridanus. And it's not just in Star Trek. There is another sci-fi book, I believe, that has the Eridani people hailing from a planet orbiting 40 Eridanus. It was believed for a while that we had discovered planet Vulcan. Now, of course, Star Trek is set in the distant future, so even if it was an accurate portrayal, it would not have happened yet. And of course, we don't believe that any aliens are going to look exactly like us, except with pointier ears and more logic and less emotion, as the famous Vulcan Spock is described, hailing from the planet Vulcan. And the planet orbiting around here, the supposed planet, was at least informally called Vulcan, but we now know, or it now appears to be the case, that the star itself is actually, after producing the signals that we believed were indicative of a planet orbiting the star. So all of these potential exoplanets, some of them are known with greater certainty than others. And if you are looking for an exoplanet, the little drop in light from the transit method of exoplanet detection, that is a little bit more reliable, it seems, than the radial velocity method, which looks at how much the star wobbles or wiggles from side to side. There are a few different ways to try and figure out if there is a planet orbiting a distant star. And sometimes these different methods, they can give false positives. They can appear to indicate that there is a planet going around a star, but under closer inspection, we can see that it's not the case, that there is actually something else going on. With a lot of these stars and planets, for example, if we turn around here to the part of the sky that the Kepler Space Telescope observed, some of these candidate exoplanets were flagged using a computer system, a computer program, to look at the graphs of light recorded by the Kepler Space Telescope and look for the kind of drops with the right distance apart to show that there was probably a planet there. But that still needed to be reviewed by human astronomers, human scientists, who were able to double check and not only weed out false positives, but also pick up on some false negatives. There were some extra planets lurking in the Kepler Space Telescope's view that were not recognized by the software that was scanning through. It had to be looked at by actual human eyes. And I think this is an important thing to mention because it shows that astronomy is capable of mistakes. And sometimes we can say, oh, there's a planet over here, isn't that great? And it turns out there actually isn't once we look at it a little bit closer. And being able to accept those mistakes, change what we believe to be the truth based on new evidence is one of the cornerstones of science. We need to be flexible. And we also need to know or be aware that when we are observing something at first, it can look certain, but the more we learn, if we go back and check again, it could have been just completely wrong, as it seems to have been in this case. So as well as discovering new exoplanets, sometimes we have to weed out potential candidate exoplanets that aren't actually there at all. And relying on software, relying on a computer program to sort through these graphs, it can definitely help cut down the work, the initial dig through of the data, but humans really do still need to be involved with sorting out this kind of stuff to some degree. The more data you have, the harder it is, But if you have enough people and enough time, we can sort through a lot of data as well, and often be more accurate than something that is just software, something that is just a series of decisions. And hopefully one day, but until that day comes, we're still going to have mistakes like this, where we think we found something and it turns out not to be the case. And even if we do perfect artificial intelligence, it'll probably make mistakes as well. So I hope you enjoyed this video, this unfortunately disappointing, but hopefully edifying video on exoplanets, their discovery and sort of undiscovery in this case. And if you are a Trekkie, well, we could turn out to be wrong again. It could turn out that there is in fact a planet going around this star. It's just not the planet we thought we had discovered when we got a signal from the star itself, or behavior from the star itself that indicated it. So we can still hold out some hope that there may be a planet Vulcan, but it now looks less likely, or at least what we believed was the planet Vulcan has now turned out not to be. Hopefully you'll join me again for my next video. You can make sure that you'll be recommended the video, or at least be more likely to if you subscribe to this YouTube channel. You can also take a look at my website, queebeanscontent.ie, where I write a little bit about the things that I discuss in my videos. So I hope you enjoyed this one, and hopefully I'll see you here next time.